Hi, this is Janakreddy Dubaka. Welcome to DJR Physics YouTube channel. This is a new series, that is Concept Spark series. In this series, we are going to discuss core concepts from each and every chapter. Generally, the students not understanding the concepts, and some concepts are misconceptional. That concepts we are going to discuss in this series. Now, this is the lecture 1 from the chapter friction. See here, friction is a contact force which is tangential to the surface in contact. For example, this is the body placed on a surface. Here, this is the friction acting tangential to the surface. This is the applied force, direction of the motion or applied force, and this one is normal reaction, and this is a frictional force. Normal reaction is also a contact force. Frictional force is also contact force. Therefore, normal reaction is perpendicular to surface in contact, and frictional force is tangential to surface in contact. Therefore, here the net force, net contact force, F is equal to square root of F square plus N square. This is net contact force. From this net contact force, here is one problem. A block is in limiting equilibrium on a rough horizontal surface. If the net contact force is root 3 times the normal force, the coefficient of static friction is, see here, net contact force Fc is equal to square root of F square plus N square. But here net contact force is given as root 3 times normal reaction. This is root 3 times normal reaction. This becomes F square plus N square. See, squaring on both sides, this becomes 3N square is equal to F square plus N square. This N comes this side, 3N square minus N square. 2N square is equal to F square. Taking square root on both sides, this becomes root 2N is equal to F. Then F by N is equal to root 2. Here F is equal to mu s into N by N, that is equal to root 2. Therefore, N gets cancelled. Mu s is equal to root 2. See, in this concept, whenever the body is at limiting equilibrium, means when a force is applied, in that case net contact force is equal to square root of frictional force into normal reaction. Frictional force plus normal reaction, square root of N square plus F square. Next one, direction of friction force. See, for example, when a body is placed on a rough surface, if there is no force acting on this body, then frictional force is equal to 0. For example, if a force F is applied, even though the body is at rest, in this case, frictional force is opposite to the applied force. Here, this frictional force, see, for example, here is a body of mass M. Here a force F is applied. Then the body is at rest. Means body rest means some other force is acting opposite to this applied force. This force is a static frictional force. The direction is opposite to the applied force. So here body is at rest means applied force is equal to static frictional force. Here static frictional force is a self-adjusting force. As applied force increases, static frictional force also increases and reaches to maximum value. That maximum static frictional force is called limiting friction. Means whenever the body is at rest, here frictional force, static frictional force should be opposite to the applied force. If the body is at rest, this applied force is equal to static frictional force. Then, so what is the direction of kinetic friction force? Here two bodies A and B. A is moving with 4 meter per second and B is moving with 2 meter per second. There is a contact surface between A and B. and another contact surface B and ground. Means here is the frictional force and here also frictional force. A is sliding on B, therefore here in between A and B there is a frictional force, kinetic frictional force, and B and ground also there is a kinetic frictional force. Then what is the direction of kinetic frictional force? See here the misconception is frictional force is opposite to the motion of the body. It is not correct. Kinetic friction force is opposes the relative motion. Therefore, kinetic friction always opposite to the relative motion. See, for example, here velocity of A with respect to B, that is equal to velocity of A minus velocity of B. See here, velocity of A with respect to velocity of A is 4 minus velocity of B is 2. This becomes plus 2 meter per second. Means here relative velocity between A and B is towards right. Therefore, frictional force on A, for example, this is A. Here the frictional force, kinetic frictional force is opposite to A. But on B, therefore this is action, therefore this one is reaction. Therefore on B, frictional force is in forward direction. Next, therefore in between A and B, kinetic friction on A is towards left, on B towards right. Then another surface in contact, that is B and ground. Then what is the frictional force? See here, velocity of A with respect to velocity of B with respect to ground. Velocity of B with respect to ground. Velocity of B minus velocity of ground. Velocity of B is 2, ground is 0. Therefore, this becomes 2 meter per second. Again, relative velocity is towards right and friction should be towards left. Therefore, between B and ground, frictional force is opposite to this one. This I am taking Fk dash. Therefore, in between A and B, on A, frictional force is towards left and on B, it is towards right, and between B and ground, frictional force is on B towards left. This is the direction of kinetic friction. Means kinetic friction opposite to the relative motion between the two surfaces in contact. This is the, from this we can find out the direction of static friction and also direction of kinetic friction. Next one, see here, analyzing static and kinetic friction. See here, this is case 1. A body of mass 10 kg, here driving force or applied force is 20 newtons, mu k is equal to 0.5 and mu s is equal to 0.3. In case 2, applied force is 60 and mu k is equal to 0.25 and mu s is equal to 0.3. See, in case 1, what is the friction? Means what is the nature of the friction? Is it kinetic or static? Okay, if it is static or kinetic, what is its magnitude and direction? Here also, what is the magnitude and direction of friction and nature of the friction? See, in first case, first we have to find out whenever the body is given, on that body a force is applied. First we have to find out the maximum static frictional force, that is Fs max. Fs max is equal to mu s on this surface n. Therefore, mu s, n means mg. Here mu s is given as 0.3, mass is 10 and g is 10. This is 30 newtons. But here driving force is 30 and the maximum static friction, this is opposite to this one. Therefore, when driving force is greater than the maximum frictional force, then only the body slides. But here driving force is less than maximum static frictional force. Therefore, the body is at rest. Means friction is static. Friction is static. But here when the body is at rest, applied force or driving force is a frictional force. Therefore, static friction, that is applied force, is 20. Therefore, here static friction is 20. In case 2, same here also F max is equal to, that is mu s mg, body mass 10, 0.3, this is also 30 newtons. But whereas driving force is 60 newtons. This 60 newtons is greater than 30 newtons. Therefore, the body is in motion. When the body is in motion, friction is kinetic. friction is kinetic. Therefore, kinetic friction Fk is equal to mu k mg. Mu k mg. Therefore, Fk is equal to mu k means 0.25, mass is 10, g is 10. This becomes 25 newtons. Therefore, in case 2, friction is kinetic, and case 1, friction is static. See, whenever any problem is given from the chapter of friction, what is the nature of the friction, and is the body is at rest or moving? If it is moving, the friction is kinetic. Then we have to test. First, we have to find out a maximum static frictional force. If the driving force is greater than maximum static frictional force, then the body is in motion. Otherwise, the body is at rest. When the body is at rest, friction is static. That too, that friction is equal to driving force or applied force. When maximum static frictional force is less than applied force, or applied force is greater than maximum frictional force, then the body is in motion. Then the nature of the friction is kinetic. Then kinetic friction Fk is equal to mu k mg. Here in second case, the body is in motion. Therefore, acceleration means net force. So here net force F may is equal to F minus Fk. Therefore, acceleration A is equal to F minus Fk by m. Therefore, A is equal to applied force is 60, but kinetic friction is 25 by mass is 10. Therefore, A is equal to 35 by 10. Therefore, A is equal to 3.5 meter per second. This is the acceleration. See here, one important point. When a relative motion has begun, the acceleration of the body according to second law, that is F minus Fk by m. For a body moving with uniform velocity, F is equal to Fk. If the applied force on the body is removed, its acceleration is minus Fk by m, and it eventually comes to rest. See, just now we seen acceleration A is equal to F minus Fk by m. When the body moving with uniform velocity means acceleration 0, that is equal to F minus Fk by m. Therefore, F minus Fk is equal to 0. Therefore, F is equal to Fk. So, very important one. When a body is moving with constant velocity, then frictional force is equal to driving force. Frictional force is equal to driving force. And next one, when the body started, after the body started, if the applied force is removed, for example, here A is equal to F minus Fk by m. Here applied force is removed, that is 0. A is equal to minus Fk by m. This is nothing but retardation. Therefore, here Fk is equal to minus mu k mg by m. M gets cancelled. Therefore, retardation is equal to minus mu k into g. See, generally in motion in straight line, for freely falling body, and acceleration A is equal to g. For vertically projected body, A is equal to minus g. But whereas in friction problems, while you are using the equations of motion, V is equal to U plus AT, S is equal to UT plus half AT square, in that we have to use acceleration minus mu kg. See, one important concept here. In motion in straight line, for retardation, stopping distance S is equal to U square by 2A. And the stopping time T is equal to U by A. But whereas in friction, the same formula, here the stopping distance S is equal to U square by 2A. Instead of A, we can write mu kg. So, very important. In any friction, if there is a friction, body is moving with initial velocity. For example, it finally comes to rest. Before coming to rest, what is the distance traveled? That is stopping distance S is equal to U square by 2 mu kg. And here is stopping time U by A, but in friction, stopping time T is equal to U by, instead of A, we can write mu kg. This is mu kg. Therefore, in friction, stopping distance is equal to U square by 2 mu kg. Stopping time is equal to U by mu kg. See, here is the one problem. A body of mass 10 kg moving with an initial speed of 20 meter per second. The body stops after 5 seconds due to friction between the body and the floor. The value of coefficient of friction is, see here, stopping time is given. Therefore, stopping time t is equal to u by mu k into g. Stopping time is given as 5. Initial velocity is 20 by mu k, g is 10, 0, 0, that is 2 by mu k. Therefore, mu k is equal to 2 by 5, that is 0.4. Here is mu k 0.4. See, another problem. Consider a car moving on a straight road with a speed 100 meter per second. The minimum distance at which a car can be stopped. Here coefficient of friction mu is equal to 0.5. So here stopping distance s is equal to u square by 2 mu k into g. Therefore s is equal to, u is given as 100. Therefore 100 into 100 by 2 into mu k is given as 0.5, g is 10. This becomes 100 into 100 by, your point in this cancel 5, 2 into 5 10, this 10 cancel, this becomes 1000 meters. This is a first concept in friction in the series of concept spark series. In future I am going to take online classes for NEET and main student. Please download DJR Physics Sir app from Google Play Store. Thank you.